Determine for the function f of x equals 4 square root of x for x is greater than or equal to 0 and less than 9, and 2x minus 6 for x is greater than or equal to 9. At the x-coordinate x equals 9, whether it is parts a through e. Each of the parts here involves the continuity of the function, so the first thing to do is write down the definition of what it means to be continuous, and that will be limit as x approaches a from both sides of f of x equals f evaluated at a. We're looking at the x-coordinate of x equals 9, so specific for this problem, we're going to look at the limit as x approaches 9 from both sides of f of x and determine whether or not that equals f of 9. We don't know that's true, so I will put a question mark above it. One of the things we need to work out here is the limit as x approaches 9 from both sides of f of x. Since f of x is a split expression function, and it's changing right at the x-coordinate of 9, to determine the two-sided limit, it will be required to work out each of the one-sided limits separately. So we can look at the limit as x approaches 9 from the left side, indicated by the negative superscript, and limit as x approaches 9 from the right side, indicated by the positive superscript of f of x. Let's start with the left-sided limit. X approaching to 9 from the left side on the number line means less than 9. And looking at the split expression function, that means we will use this for the expression 4 square root of x. We can replace f of x with 4 square root of x. The next thing to do is try plugging a 9 in for each of the x's. That will give us 4 times the square root of 9. The square root of 9 is a 3, so 4 times 3 will give us a 12. Now we can look at the right-sided limit. The right side of 9 on the number line is greater than 9. Looking up here at the split expression function, that means we will use this for the expression. So we can now replace f of x with 2x minus 6. The next thing to do is try plugging a 9 in for each of the x's. That will give us 2 times 9 minus 6. 2 times 9 is 18 minus the 6, and 18 minus 6 comes out to 12. The two-sided limit is determined by the results of the one-sided limits. Here they are, they match each other, and therefore the two-sided limit will be that same value, 12. The next thing we need to figure out to determine the continuity is f evaluated right at the x-coordinate of 9, f at 9. Now looking at the split expression function, we want to see where x can be a 9. That's where it's included, and that'll be here since it's greater than or equal to 9. We will use 2x minus 6 for the function right at 9. And 9 will be plugged in for the x, so this will give us 2 times 9 minus 6, which is 18 minus 6, and that comes out to a 12. So our results here are that the two-sided limit as x approaches 9 of f of x does equal f of 9, or another way to say that is the left side limit of f of x matches the right side limit of f of x and equals f of 9. When these equal to each other, we have situation A happening, and it looks like we have continuous at x equals 9.